Good to go?
It's a go,
All
yes.
right. Well, hey, that was great, Wish. It was good that you went first because I can tie mine in quite nicely and from what I would call legacy data centers because being here and being in part of the data center world for about the last 30 years, it's been an interesting journey to say the least. So before we get started, I'd like to share a little bit of a story, and thanks for having me, by the way. It's about technology. And it wasn't that long ago where all these companies would build their own computer rooms hidden behind closed doors to secure their data, or as I call it, their crown jewels. Think of these rooms like a bank vault, but only for IT equipment. Now, over time, these organizations would experience major outages within their environments, and it was very concerning. This led to conversations around redundancy, building a second room or facility in case something happened to the first one. And this was a very expensive venture back then. However, what is the cost of losing all your data? Well, it was priceless. This created an opportunity for co-location services. Companies would build these massive data centers designed to house the customers' crown jewels, and multiple businesses were able to share in cost savings and efficiencies within one facility. This was an attractive offer versus each of these organizations going out and having to build their second facility and managing it themselves. Then a thought came to mind. Why stop here? What other services can be provided? Customers will come and ask, it would be nice if we didn't have to purchase the IT equipment. We just give them the requirements that we need and they provide it back to us as a service. Then we don't have to drive to site any longer. Well, this was the start of managed services that evolved into cloud computing. And everybody has obviously heard of the cloud. Simply put, you go from owning and operating your own data center, and someone comes along and takes the keys from you, which you no longer have physical access to the data center space. You only have access to the applications that you need through the network. And this is what they call cloud. There's one little caveat, though, that people sometimes don't understand is that the proprietary information or that secret sauce of these organizations, they didn't move to the cloud. They stayed on-prem, which means now you've got two facilities. Now, show of hands. How many of you got a device? How many of you got a bunch of devices? You might have a laptop, tablet, smart TV, or you got a refrigerator that knows when you need to order your next jug of milk. Well, this is what they call IoT, the Internet of Things. All these devices allowed everyone in the world to connect to data information. And as you can imagine, this also created challenges. And let's talk latency. So latency became a huge issue with a number of devices out there. Accessing data was in high demand. This created the need for edge computing, bringing the equipment and applications closer to the end user, allowing them to connect to the data that much faster. So the reason why I'm telling you this story is because I've been told throughout my career that the data center business was going to go away. Well, I've been doing this for over 30 years now, and I can assure you, data centers are not going anywhere, and today is a great example of that. So let's talk AI. It's a natural progression in the evolution, although it's a huge step due to the complexity, as Wish shared earlier. The simplest form of AI is like a search engine. It collects as much data that is available on a specific topic, making decisions based on our behavioral tendencies. Then it processes it as fast as possible, and then it gives it back to you as feedback. Well, this requires serious horsepower. So for everybody's sort of understanding, or one video that's produced by AI consumes about 3,000 watts per hour. Your home air conditioner consumes 3,500 watts per hour. So it kind of gives you an idea of how something so simple would be so dramatic. Another one where you've got your legacy data centers I showed earlier, modern to hybrid cloud. Then you jump to AI on the right-hand side here. Well, that's a huge jump. It's drastic changes. Okay. So now let's dive into the opportunities for everybody. You may have heard of a gentleman by the name of Kevin O'Leary. he's put out a video online. You can go, if you haven't checked it out, go have a look. Basically, it's about Wonder Valley, and it's a rendering that kind of explains what's going to go on up in Grand Prairie, or the hopes to be able to do that. So these announcements referencing these mega facilities looking to come to Alberta certainly raise awareness, such as your group and the marketplace. And what will these things look like, and when will they get started? Well, let's just share some excellent insight that's going to be some years before that's going on. Excuse me. And as of today, there's a large number of these major organizations who've shown the interest in landing these massive environments that equate to the size of a new city, and turning them on in a couple of years, that's just not going to happen. And there's multiple of them. The great thing about the ways around data centers is the fundamental construction of a data center by today's standards can operate on their own indefinitely without concern. So they can probably build a little faster than maybe the grid can accommodate. So there is obviously opportunity there. But here's what is not being talked about: existing data centers. This is a rendering of a typical layout for an enterprise data center. One thing to note, these customer-owned data centers in Alberta typically have about, I'd say, 50% available capacity within them. See, over time, new equipment that comes in, it gets more efficient, so the power never really jumped that much. That's why you saw on that graph I showed earlier, it doesn't show you, leaps and bounds of power over time. However, AI is drastically changing that. So remember my comment a little earlier about customers not putting their crown jewels or their secret sauce into the cloud? Well, they're not going to give that information to just open AI. They're going to do that themselves. So they're going to build their own AI within their own environment so they can control that. So if I take an example, let's pick on half of a facility, so that this one here has got 100 kilowatts of load, and they're at 50% capacity. That means 50 kilowatts is available. Well, in today's term, easily can do that with 50 kilowatts under one rack. That means it is 10 times more than a traditional 5 kilowatt per rack design and deployment. So if you're jumping that up, and then, of course, and this is a very conservative number for AI because they're talking upwards of 500 kilowatts to come, but we'll just stick to the 50 kilowatts. So a fun fact, you need 5 kilowatts to power a medium-sized home. That's your availability aspect. So 50 kilowatts out of one rack, it's pretty substantial. Cooling infrastructure now becomes a potential concern, not to mention the power. So this is a purpose-built environment that has existing efficiencies already built into it for growth and future availability, but based on today's standards only. So now it's not very accommodating for AI type of applications. The challenge now is inserting various requirements for new AI loads, dramatically increases loads over 10 times the normal power that is provisioned for each rack, and then some, of course. So here's an illustration of a particular system, which we call a busway system. And it allows you to power a solution in a very quick manner and be able to plug and play. So you get into more of a modular aspect, like Wish had mentioned earlier. The challenge is that your infrastructure now has to go up because you're adding that much more power to that, and you got to power up even the thermal aspects of it. Here's a close-up of the system that I was just showing. And here's an old deployment. And this is an exact example of being able to provide power to accommodate this one rack at 50 kilowatts. So you see on the top side here that there's two tray systems, one's your A and one's your B. And each one of these traditionally are 60 amps, and they would do 17.2 kilowatts each, which means you get one side would have to be with three of these connections is 51.6 kilowatts. And then you need your redundancy, so you need times 2, so you got 6 of these power receptacles. Now, fun fact is that particular blue receptacle spans from your wrist to your elbow. That's how big these things are. So it gives you kind of an example of how much room that these things are going to need. So the new technology that's coming has got to be that much more efficient. Here's a quick example of what goes on behind the data center walls. Here's some great infrastructure that's put in there. This would need to be upgraded and added to just by adding in more AI equipment. Another component to support the AI is a thermal solution. Shown here is a liquid cooling infrastructure that would be needed to be added within the room. You got your CDU, which is your cooling distribution unit. You have your overhead manifold that's all stainless steel. And then at the very top, which is showed in the previous slides, which is your overhead power. So this kind of gives you a little illustration. You see the back of the racks over here, they got fans on them. These are called rear door heat exchangers. That allows the hot air to pump against them, and then it deploys into that environment so it doesn't affect too much to the existing data centers infrastructure from a cooling perspective. Here's a close-up of the CDU that I mentioned before. It connects to the overhead manifolds. And here's the in-rack example where they've got vertical manifolds that would tie into each part of the equipment. And with these vertical manifolds that connect into these servers, it's important to know that if you're involved as a technician or maybe even as a business owner or facilities individual, this is going to be newer technology that you're going to have to be aware of that's going to be inside of your environments. It's very exciting. So here's a great example of what's going to happen. The bottom part here you got your existing infrastructure. You're going to need to add in like rear door heat exchangers. That's at the bottom of this one square here. So you're going to add like another 25% of server heat rejection to air in that facility by adding the AI components. The top part here with the new manifolds, the CDUs, and the heat rejection and condensers on the roof, you're basically doubling the size of your infrastructure for thermal. So there's not only are you adding more power, you got to add more thermal capacity, and it's just going to augment everything that's out there. And those opportunities are real today because all the customers are talking about putting AI in their existing facilities. But here's the fun fact. They don't have to tell ESO about any of this is going on because they've already built out their facility to take on 100 kilowatts. Right now, ISO is looking at it from that facility's is maxed out or is actually drawing 50% of its load. All of a sudden, you got all these environments are going to start jacking up their power requirements, and that is going to maximize each one of these facilities, and then some. So I'll stop there. Basically, there is a number of things that need to go on with inside of a data center facility. I've got shown here, like you got your power management aspects. We partner with a group called Vertiv. They've got a number of different companies that they've bought over the course of time. We're a organization that has done a lot of design, build, and helping customers augment their existing environments. And there's lots of ways to be able to handle different situations, but it depends on the type of environment. That's all. Thank you.
Thank you, Darren. Oh, wow. Okay, now that is even more information. And I am wondering, so not everybody here understands all the technical stuff that is going on at the background. And it's interesting to see that, we just here using ChatGPT, just using our AI tool, and sometimes we don't think about what that really looks like in terms of infrastructure. So this has been eye-opening in that sense. And so my question now is, what does this all mean practically for economic development? And we're talking about the Alberta advantage, which you mentioned that you are involved in data centers across the US, and we are trying to attract companies to come and build them in Alberta. What's the Alberta advantage, and is this likely to happen? Because given all the things you said, I'm like, okay, this sounds like there are more reasons why it will work than we have that will make it work. So now I'm just wondering, what does the feasibility really look like that will have massive data center villages here in Alberta?
Yeah, I don't know if we'll have massive data centers in Alberta by that scale. There will be a few built. Our advantage is that we have cold temperature. We have
Mm-hmm.
really, really cheap natural gas, cheap electricity, and also that we have like a lot of engineers. And that's our mode. And then we have cheap land. In Virginia, it's like probably very, very expensive now. Land over here is very cheap compared to what you pay in Virginia. So those are our advantages. In terms of how many are going to get built, I can't comment on that because I'm privy to some of those conversations. But I can tell
Yeah.
you that it's not going to be all of them. And the reason is basically, I'm sure you guys heard about the DeepSeek when it came out. Uh,
Mm-hmm.
I think the best analogy that I can give you guys is that the electrical, the grid doesn't care about software. It's physics, and it's a hard, tangible asset. And but the software world, like the big shops who have billions of dollars to spend, they don't operate that way. So essentially, Facebook comes in, or it doesn't even have to. Mid-cap shops come in. They'll be like, "I'll spend $500 million on this. Can you do it quicker?" The grid doesn't work that way because physics is finite and it's got principles. Throwing money at the problem doesn't solve the problem. It's more so in here, you have to talk to the electrical engineers and convince them that it's not going to cause any stress on the grid. Because when you do stress the grid, the other analogy that I give is, how people can drink 2 or 3 Red Bulls? The grid cannot drink a single Red Bull. It cannot. It literally, there's something called a 60 hertz. And that frequency is, if it deviates even slightly, it can have a brownout, which is what happens in a lot of third world countries, right? Because the grid is not stable. Over here, it's stable, but it doesn't take much to, spark it, and then you have brownouts, and suddenly then that a hospital doesn't have any energy, right? And so that's why this is so hard to do.
Mm-hmm. So if we're relying on natural gas and not our current grid, like is it possible to actually build whatever we're building off of a new power source, not tapping into whatever we need for day to day?
I think Darren would know more about this, but based on
Mm-hmm.
the AI data centers that I've seen, even if you bring your own power, right? The problem is the engineering. So I'll give you an example. So some of the data centers that I'm working on and for the AI data centers, they have these things called SLAs, service level agreements, right? 3 nines and 5 nines, and Darren's smiling. So if I have a contractual obligation as a data center provider to make sure that the AI GPUs that I procured are going to be available to me when I need them, and then the data center goes down, right? Which can happen because
Mm-hmm.
they brought their own power and the power plant went down. Well, now you're in violation of your SLA, which is
Mm-hmm.
not $10,000. It's in the tens of millions of dollars, right?
Right.
That's where it's hard because if the data center people bring their own power, problem is the data center people don't understand power, right? Like they don't operate power plant. That's a 2 different worlds. And so the engineering
Mm-hmm.
becomes even more complex because now they're going to be not only responsible for a power plant with a Siemens or a GE turbine, they're also going to be responsible for something called gas that goes into the turbine, and that's fuel. So when you have a power plant that is a 500 megawatt power plant that's taking gas, your burn rate just for gas for power can be 30 to $40 million, right?
Mhm.
That's your OpEx.
Mm-hmm.
It's not cheap. So,
Yeah.
thinking your own power has different problems.
Darren, any further thoughts?
Yeah, no, he's spoke very clearly. One of the things that I touched on earlier is about redundancy. So you're relying on gas as your primary source. If you lose your gas, what's your second source of power to be able to meet these SLAs? Do you have diesel generation? I mean, we're talking some serious power there.
Yeah.
Mm.
I'll give you guys an idea, right? Like, so 7 cents a kilowatt, right? That's power price. Just to say, that's what a data center agrees to buy from a power plant of 500 megawatts. Okay. That translates to, because you have to keep in mind, a data center, an AI data center, when they switch it on, it goes on for months at 100% capacity, right? So if you have a 500, like a Ferrari with a V12 engine running constantly with the person pressing on the gas until the AI model is done training for 30 days straight, you're treating your Ferrari like a lawnmower, right? And essentially what happens is now, if you want to translate that to a dollar amount, 7 cents a kilowatt hour, doesn't matter what that means, but like for power, for a 500 megawatt, your operating cost for 1 year for that 500 megawatts is anywhere from 300 to $500 million. So you buy the data center, which costs you billions of dollars. You buy the GPUs, which cost you hundreds of millions of dollars. You figure out the engineering. Now you got to pay the money for the fuel that goes into the power plant or the power, right? So when you talk about that scale, those numbers are very scary.
Murad has a question in the chat, an interesting one. Do you want to unmute and ask it yourself, Murad?
Yes, I can. So, hi everyone. The question is related to the CapEx and the OpEx of AI powering data centers. So, in order to power AI data center, we have to spend, or let's say, companies have to spend a huge amount of money to, like you wish already said, to develop data center, to organize the power plants, to connect everything, to organize the dependencies and backups. And now main models like ChatGPT for consumers, they are very cheap, if not free. So what is the reason behind?
Cannibalization, that's what they're looking for. Anybody that can capture market share is where they're going to go. So if they don't discount the prices, open source models will take over. Or, like Llama, which is Facebook's model, 3.1, 450 billion parameter model, that's free. Anybody can download it. The problem is that people don't have the hardware to run it locally. But the DeepSeek model that came out, I've done like 6 or 7 deployments now. You can run it on 4 NVIDIA GPUs in your basement.
Yes.
Right? So depends. That's why they're trying to compete. But ChatGPT is coming out with 3 new subscriptions, $10,000, $15,000, $20,000.
I know.
Those ones are agentic, right? And they are gonna a month, and let's do math. Let's just say the most expensive one, $20,000 a month. I think that's the most expensive one. USD translates to about $240,000 for that one agent ChatGPT subscription. Now, people think that's expensive, but it's not, because that agent system that they're building is, essentially as good as 10 PhD people. In US, if you have a PhD, let's just say in a specific field, and you pay them $1 million, well, now you have 10 of them for $240,000.
That's
Right.
a whole lot to think about. So, I mean, doesn't that also mean that generative AI, the way it was rolled out to the public, is really not sustainable? It's just a way of getting people to pay attention and getting us hooked so that they won't have a choice. We have to live on that. Because if the cost of operation is this high, as like Murad was saying, then it really cannot be sustainable if they don't put meaningful subscriptions behind it.
Depends for who. For OpenAI, probably not, but they have a big funding round, right? They keep raising money. But for Microsoft, that leases these models, they make a lot of money, right? Because they lease, and Darren pointed out very nicely, they're called colos, right? They're rental data centers where Microsoft will go and purchase the lease.
Right.
They're not on the hook for the CapEx or any of that. And then that's what you're seeing. Yes, today and like a few days ago, Microsoft has been canceling a lot of data center deals on the AI front, not the legacy ones. And the reason is they're like, it'll be too cheap for them. So it depends on who you're talking for.
Let's see. Darren, I wanted to ask, so you gave some history about the evolution of data centers, and you said you've been in this business for 30 years. So why the buzz now? We know it's driven by AI, but what's going to be different? Is it a baseless buzz, or is it what needs to change because of more of the awareness around data centers? Because we've always had them, like you said, and in this vying where different municipalities, economies are trying to attract, what's likely going to be the outcome of that?
Well, I think from my personal opinion, when I look at the news and how everybody talked about data centers in the past, like I've walked around the streets for years, said I'm in the data center business, and nobody knew what that meant. I had to use movies to actually kind of, share. Have you watched this movie and it's got a data center in it? And, that was the way that I could get across. So it's really tough. Then all of a sudden you've got all this noise with Amazon or AWS and Meta and such, and they're talking about building these massive facilities that are going to be gigawatts, and it's all over the news. Then you got Kevin O'Leary that puts this video up there and says it's going to be green and wonderful and in a nice pasture. And anybody that's in data center has a good smile and a giggle, and it's a lot of infrastructure in there. So I'm kind of glad that it's now something, because for years it's like I do a cool thing, but nobody knows about it.
And now, in terms of opportunities, so if you're going to be building all the pictures you were showing us, both of you, Wish and Daring, this is a lot that has to go in. So we're talking about tradespeople, engineers, electricians, all of that. So this poses a huge economic opportunity if we can pull it off. What would that look like for everyday people? And is there some upskilling? So this our community is full of people that are interested in technology one way or the other. So if we need to upskill, what opportunities do we need to be taking advantage of before, so that we are ready when the opportunity shows up?
Well, one of the things, sorry. One of the things that I find that's really needed right now is it's a human element. So you got business and you got IT and you got facilities. So people that are in business need to understand the complexities that go on with running your own data center or AI within your own environment. You have to have policies and what that looks like. IT's got to be able to maintain and keep things running at 100%, because there's no way that anybody's going to tolerate having taken an outage anytime. And facilities has got to make sure that they've got planning involved, and their infrastructure is going to support all of this. Those three live in silos, and they have forever. They're taught in school in silos. They come to work, they work in silos. You get them at the table, they don't see eye to eye. And that's the toughest part about building a proper infrastructure. So anybody that's looking to understand the opportunity, it is super important that those three elements are an opportunity for anybody. So if you're going to do IT, if you're going to do business, if you're going to do anything in the tech environment or facilities, it's very important for you all to connect, and that's an opportunity.
That's awesome. I like making things connect.
Mm-hmm.
Like if there's anything I really like doing, it's when I see gaps where there's opportunities for two or more things to speak together, and there's more efficiency, there's more synergy, it fires me up. So we need to be building solutions that connect business, IT, facilities together somehow.
Yeah,
that's awesome. I'm just going to look through the chat before I get too excited with my own questions. So, Minu. Okay, I think that's similar to the question I just asked in terms of trends in technology, what this all means. So, which mentioned that paying 20K using multiple subscription is cheaper. Does this mean we should start worrying about our jobs? The age-old question.
No. I mean, depends. If you're in trades, no. Electricians, plumbers, welders, great field to be in. They're always be in demand. If you have to depend. If you're in, I'm not going to say any industries. Actually, it gets me in trouble every time. But I think people need to learn AI and incorporate it in everyday life. because it will enhance you. It'll help you do your job better and faster. I mean, everything that I do has like AI component to it now. And it's enabled me like stuff that used to like I'm a programmer as well, like I code. Stuff that used to take me about 3 or 4 months to kind of code takes me about 3 hours now, 3 to 4 hours. Building production grade systems and fixing stuff, writing documents, legal, etc. Like it takes me 5 to 10 minutes now. Depends. Like, I would doesn't matter if jobs or not, but you need to learn AI. That's a definite yes.
Darren, any thoughts on that?
No, nothing I could add.
Mhm.
Yeah. I just realized that today is actually International Data Center Day.
Oh, I did not even know that.
Yeah. Saw it pop up this morning, and I thought I'd better write this down because it's the fourth Wednesday of March, I guess, is how they coin it. So
Mhm, mhm. And Ovo has a thought there. The PhDs who are able to take on AI skills and able to understand their domain and fine-tune models will be fine. Yeah, totally, totally. Well, this is definitely a conversation that needs more than 1 hour to really do justice to. But we really appreciate you so much for being here, Wish and Darren. We know how busy you are. We know this time you have given us is so precious, and we don't take that for granted. Thank you so much.
You're welcome. I'm gonna leave my LinkedIn on there on the chat group, so feel free to add me on there if you have any questions. Take care, guys.
Yeah, thank you so much, Wish. Thank you, Darren.
my pleasure. Thanks for having me. This is really good. Appreciate it. Nice meeting you, Wish.
You too, Darren. Okay, bye.
So we will still have the room open for the next 10 minutes or so. If people want to stay back and hang around, and if you have any other questions, feel free to stay. If not, you have a great evening, everybody. So Nova is going to be sharing the link to our Discord channel one more time. So if you're not part of Immigrant Techies Network yet, we will we'd like you to join us. All right. Thank you, Wish. Thank you, Darren. You have a great evening.
I'll stick around. I got 4 minutes. So.
Yeah.
Okay, nice.
Okay.
Nice.
Stick my.
So yeah, people, this is the time where feel free to unmute yourself and ask your burning question. Please go for it. Ole, are you saying something?
Mr. Wish, is it possible to have something like an internship with you? Just to learn. This is the second time I'm seeing you. The first time was on the Church Innovation Hub, where you presented AI in that hub. I was there too. So this is the second time I'm seeing you. So if there's an opportunity to learn from you, I'm open to that. I don't need any money, just to learn. If it's possible. I'm being honest. Yeah, so
right, I'll try.
no
promises.
Or we can take it off the chat.
I mean, it's there are so many opportunities to learn, right? So many theoretical opportunities you can start with, and of course, see, Ovo is giving you ideas of where you can learn from. Okay, no, yeah, deep learning AI is a good place to start. I don't know if that was okay. That's it. Someone else's question, but it might be useful for you too as well.
I have some experience in data science, so getting that practical knowledge from him, from the angle. I don't want to learn theory. I want to apply it to certain practical knowledge, so I can have that broad knowledge. That is I just finished master's degree in University of Calgary, data science. So I need some other, not reading theory now from the book. Yeah.
Yeah, I mean, you can reach out to Wish on LinkedIn. For sure. Awesome. I'm just gonna stop.